Well, hello again. Today we want to look at the periodic table and the trends in the periodic table. Let's start up with some basic information. What is the periodic table? The periodic table is an orderly arrangement of elements. Periodic table, an orderly arrangement of elements. The periodic table is arranged in groups and periods. The groups run vertically. While the periods run horizontally. The groups running vertically, like that. The periods run horizontally, like that. Okay? Now, the periodic table is based on the electronic configuration of an atom. As you recall, electronic configuration speaks of the distribution of electrons in shells. We'll review that in a little while. And then, of course, we need to look at valency. In review, your valency will be equal to the number of electrons in the outer shell. Valency, the number of electrons in the outer shell. Now, just by way of example, if we're looking, for instance, at sodium, mass number 23, atomic number 11. It means that I'll have 11 atomic number, I have 11 electrons, 11 protons, and by subtraction, I'll have 12 neutrons. That's review. Now, I have 11 electrons. It means the electrons are distributed 2, 8, and 1. 2, 8, and 1. I have 1 electron in the outer shell, which is referred to as the valency. 1 is the valency. I've used 3 shells. Now, if I have 1 electron in the outer shell, it means it is in group 1. I've used 3 shells, it is in period 3. Therefore, looking at the atomic structure of sodium and working out the number of electrons and distributing the electrons in the shells and deriving the electronic configuration, I will be able to say what the valency is. I have a valency of 1. I'll be able to say the number of shells used, which will be equal to my period, and I'll be able to look at the number of electrons in the outer shell and assign it as the group. So, the periodic table, an orderly arrangement of elements. It is arranged in groups and in periods. The groups run from top to bottom. The periods run across. Electronic configuration, the way the electrons are distributed in the shells, and the valency, the number of electrons in the outermost shell. Now, let's look at some examples to see if we could work out the group and period with which the element is placed in. Let's look at calcium. Calcium 40, 20. It means I have 20 electrons, 20 protons, 20 neutrons. 20 electrons and protons are the same, subtraction, neutrons, 20 neutrons. I'll have 2, 8, 8, 2. Electronic configuration of calcium 2882. I have, let's look at the number of shells. 1, 2, 3, 4. 4 shells. 4 shells, therefore, it is in period 4. Number of electrons in the outer shell, I have 2. Therefore, it is in group 2. Again, looking at the number of electrons present in the atom, I'm able to distribute the electrons in the relevant shells. From there, I can look at the number of shells used and assign the period. The number of shells will be equal to the period. The number of electrons in the outer shell is called the group. Another example. Let's look at aluminum. Aluminum, 13 electrons, 13 protons, and by subtraction, 14 neutrons. 13 electrons will be distributed 283. 283. Now let's see, I've used 3 shells. Therefore, period 3. 3 shells, 1, 2, 3, period 3. Number of electrons in the outer shell, 3. Therefore, group 3. It means, therefore, that we could look at any element, work out the electronic configuration, see the number of shells used, assign the number of shells to the period, the number of electrons in the outermost electron, also called the valence electrons, or valency, will be equal to my group number. So we can see how atomic structure relates to the periodic table. Remember, as I said, the periodic table is an orderly arrangement of the elements. Elements are assigned to groups and periods. We can look at the period from the electronic configuration by looking at the number of shells used, while the number of outermost electrons, or the valency, will be equal to the group number. All right, now let's continue. Now, there are a series of groups that we must be familiar with. There is group 1. Group 1. Group 1. We have hydrogen, lithium, sodium, potassium, rubidium, cesium, and francium. That's group 1. Okay? Now, group 1 is called the alkali metals. We have group 2. Group 2. We have beryllium, magnesium, calcium, strontium, barium, and radium. Okay? We have group 7. Now, group 7 is fluorine, chlorine, bromine, iodine, and astatine. And then we have group 8. Group 8. We have helium, neon, argon, krypton, xenon, and radon. Now, it's important for us to have a general idea of these groups. Group 1 is called the alkali metals. Group 2 is called the alkaline earth metals. Group 7 is called the halogens. And group 8 is called the inert gases. The inert gases, also called the noble gases. Okay? Now, just a little note, the noble gases, because their outermost shell is completely filled, the noble gases will be inert or unreactive. Inert or unreactive. Group 8 being inert or unreactive. The halogens, fluorine, chlorine, bromine, iodine, acetylene. The halogens group 7, alkaline earth metals, we have them there, and group 1, the alkali metals. Now, take a look at that and you may want to record it. All right? It is also important for us to know the first 20 elements in the periodic table. You must learn that by heart, the first 20 elements. Take a look at this and we come back. All right, let's look at some trends of the periodic table. Now, as we look at the periodic table and we go from group 1 to group 8, we're going across the periodic table, moving from left to right. We go from metals to semi-metals to non-metals. That's something we need to consider. We go from metals to semi-metals to non-metals. There is something else we need to consider. We go from large atoms to small atoms. We say that the atomic radii decreases as we go across from left to right. We go from metals to semi-metals to non-metals, and the atomic radii decreases. All right, now, there's something else we need to see. All right? As we move across from left to right, there are oxides. The oxides of metals will be basic oxides. The oxides of the semi-metals will be amphoteric oxide. And the non-metals will be acidic oxides. Okay? The type of oxides will vary. The metallic group, basic, the non-metallic group, amphoteric, and the non-metals, acidic oxides. All right. Now, we must consider something else with respect to trends. Let's look, for instance, at group 2. As you go down group 2, as you descend group 2, the atomic radii, it will increase. It increases. It means that the electrons in the outermost shell in the last element of group 2 will be further away from the nucleus. It means, therefore, as we go down group 2, reaction rate increases. The reaction becomes faster as we go down. Why is that so? Because the electron in the outermost shell as we go down is further away from the nucleus, and that electron can be lost easily. The atomic radii increases as we show on this diagram. There is something else to consider as we look at group 2. We'll need to look at the reactions with acids reactions with oxygen and reactions with water. Now, let's look. Reactions with acids. Take calcium, for instance, plus hydrochloric acid, and we'll form calcium chloride and hydrogen gas. Whenever the acid reacts with the metal, a salt and hydrogen gas. Again, balance the equation. Reactions with oxygen. Calcium with oxygen will form calcium oxide. Calcium with water okay, so there are three things you need to consider with respect to the reactions of group 2 metals, with acids forming the salt and hydrogen, with oxygen forming the oxide, and with water forming the corresponding hydroxide and hydrogen. But notice something, as we go down group 2, the reaction rate will increase. Why is that so? The size of the atom increases, the electrons are lost faster. Take a look at this, we come back. Right, let's look at group 7. Group 7, as I said, we call the halogens. As we go down group 7, what do we notice? Is the size of the atom increases. Why? We have more shells, obviously, and so the size of the atom increases. But the reverse takes place here as we compare it with group 2. As we go up, reaction increases. As we go up, reaction increases. Why is that so? The smaller the atom, the easier it is to gain the electron. And remember, in group 7, it needs one electron to complete the shell. And so the smaller atom will attract the electron faster. The reaction will increase as we go up. Now, group 7 is a very interesting group because in that group we have solids, liquids, and gases. As we go down group 7, we go through the states of matter, the 3 states. All right? So we have gases, liquids, and solids. Gases, liquids, and solids. So we'll have, for instance, your fluorine and chlorine being gases, bromine being a liquid, and iodine and acetylene being solids. All right? And why is that so? As we go down the group, what we notice is that the bond length decreases. The 2 atoms come closer together. All right? As we go down, the bond length decreases, or we say the bond strength increases. The atoms are held closer together, and as you know from your states of matter, the closer the particles will be present in solids, the further the particles will be present in gases. Now, we also need to be reminded of this as we go down group 7, the reaction rate will decrease. Or, as I said before, as we go up, the reaction rate increases in group 7. The reason is the smaller the atom, the faster the electron will be attracted. So we have, so far, we have group 2, we have group 7, we said group 8 is unreactive, it's already stable, and we also have the trends across the period as we go from your metals to semi-metals to non-metals. Now, also take a look at this. Looking at your oxides, okay, there are basic oxides, there are acidic oxides, there are amphoteric oxide, and there are neutral oxides, types of oxides. The oxides that are basic are oxides of metals. Oxides that are acidic are oxides of non-metals. Your amphoteric oxides will be zinc, lead, and aluminum. Learn that. It is a common question on your multiple choice exam. The amphoteric oxides, zinc, lead, and aluminum. Your neutral oxides will be carbon monoxide and nitrogen monoxide. Now, an example of a basic oxide will be calcium oxide, oxide of a metal. Oxide of a non-metal, carbon dioxide, nitrogen dioxide, sulfur dioxide, acidic oxide. Okay? Take a look at that and you may record. Well, I trust that this has been helpful for you. Looking at the periodic table, orderly arrangement of elements, the way the elements are arranged in groups and periods, looking at the trends in groups 2 as well as group 7, and looking at the trends as we go across a period, and then looking at the oxides. Take a look and you may want to write that down.